They are, he's saying this to shows the relative abundance of two natural occurring isotopes of copper. That means if you see in the Earth's crust, you find copper, you look for copper, you will have two masses of copper. You will either be a 65 copper or a 63 copper. 65 AMU copper or a 63. But the abundance will be 70% of it will be this copper and 30% will be this copper. So he is saying calculate the relative atomic mass of copper to 1. So one thing is clear that he is asking you to calculate this, the relative atomic mass. The other thing you should notice that like many isotopes, even carbon as comes in C12, C13, C14, hydrogen 1, 2, 3, chlorine 35, 37, even bromine comes in many isotopes. So even sometimes what happens is the carbon atom inside a molecule, one will be C13, one will be C12. Okay. C14 is a radioactive, it just goes away. Like here in chlorine, like you've got a molecule, let's say you do haloalkane, you will know, I'll tell you what that is. Like let's say you have C2H5Cl, oh sorry, C2H5Cl, sorry, C2H4Cl2. Now, if you have e- one carbon and two carbon, so this carbon can be 35 or 37. Here, the carbon, one can be 35, the other can be 37, both can be 35, both can be 37. Many possibilities are there. The chlorine could be any of these. The chlorine could be any of these. The chlorine could be any of these two. So these many combinations are possible. So one thing is clear when we look at whenever there are two things. One is average, one is weighted average. So here we have to find the weighted average. The weighted average. What is weighted average? We give importance to the thing which is in more percentage. So supposing something is in less percentage, then we give it less importance. So the formula to calculate the weight is this mass into its percentage availability. This is the weighted average. So that means we give it, if it's 35 is available 75% of the compounds, and 37 is only available in 25% of the molecules, then we say, okay, if we have to use the chlorine atomic mass, we will multiply this by 0.75 and this by 0.25 and get the average, because they put in the periodic table. Some people use decimals, some people use this percentage, that means 75 over 100, but they're the same thing. So here what we'll do, we'll do the same thing. We'll do 63 into its percentage abundance plus 65 into its percentage abundance, and whatever we get, that is we will put on the periodic table. So let us do this. So it's 63 63 into 0.7 plus 65 into 0.3, that's 63.6 he's putting. So this works out to be 63.6, and that's why they I don't know what values they have given, but copper is somewhere near this only. Okay, 63.5. So that's how you would see the weighted. Had they been equal, then I would have just used the average. That means I would have done 63 plus 65 divided by 2. Supposing I get 50-50, na? 50-50. Then I would have done this. But this is not the case, because they are found in, uh, like what I would have done was, supposing they are 50-50, that's 63 into 50 plus 65 into 50% over 100, right? So what's that? 63 by 2 plus 65 by 2. That's 63 plus 65 by 2. So that's finding the average. Like in statistics, stats, we do mean, median, mode. Mean is just the, what is mean? Mean is uh, number of the all the observations by divided by the total number of observations. So there are two observations, 63 and 65. They are equal and there are two. So we do this. But if they are not equal percentage wise, 70%, we use the weighted average. So in probability, you will do this. Probability distributions, you will do weighted average. I hope you understood. Huh?